Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 22 of AWS DevOps Zero to Hero series, and in this video we will deep dive into the concept of EKS, which is Elastic Kubernetes Service. This video is a really important one because Kubernetes is the most required skill in a DevOps engineer's job role these days. And if you are an aspiring DevOps engineer or an aspiring AWS DevOps engineer specifically, EKS is the one that you need to learn for sure. And in this video, I'll make sure that you will not just learn the concept of EKS, but by the end of this video, you will also learn how to deploy a practical real-time application on the AWS EKS platform. And if you see here, this application is deployed on a public facing IP, or it is accessed through the load balancer. So we will deploy this application onto the Kubernetes platform. We will create a service, we'll create Ingress controller, and we will access this through a load balancer. And of course, we will create a VPC with public private subnet and install this inside that private subnet. So it's going to be a really cool demo, and this can be one single demo that can convert your project or that can convert your resume into a very impressive one. So please watch it till the end because we are going to do step by step with a lot of configurations. So before I go through the demo, as usually, I'll explain the theory part. What is EKS? Why EKS? And I'm going to cover some important interview questions such as why you need to go with EKS, when you need to go with EKS compared to the other Kubernetes distributions or an on-premise Kubernetes solution. So let's quickly start with it and understand EKS. So I'll not take much time here because there is already a Kubernetes playlist on my channel where I've explained all the concepts of Kubernetes, and it's almost like a 15-hour playlist where you can follow that playlist and learn Kubernetes end to end. So I'll put the link in the description so that you can go back and watch Kubernetes videos if you're not aware of Kubernetes. But assuming that people who are watching this video, they have at least fundamental understanding on Kubernetes. So EKS is basically a managed Kubernetes offering, like I told you. Now, what does that mean? So if you have a Kubernetes cluster, like if you have created a Kubernetes cluster in the past, you will know that typically in Kubernetes cluster, there are two components, right? One is the control plane component. And then there is another thing called as data plane, or people can also call it as master nodes and worker nodes. And there can be single master, single worker. There can be three masters, three workers, or depending upon your organizational requirements, there is no limit. But the ideal thing is if you want to set up a high available Kubernetes cluster, then go with the 3-node Kubernetes master architecture, right? So now let's say you don't use EKS and let's say you want to do it all alone, but you are already on AWS. Then typically what you will do is you would sign into your AWS platform. And let's say you want to create 3 master node, 3 worker node architecture. You will spin up 6 EC2 instances, 3 for master nodes, 3 for worker nodes. And what you will do is initially you will start with installing the configuration in this master nodes. Like master node typically has some important things like Masternode has an API server. In Masternode, you have etcd, you have scheduler, you have cloud control manager, there is controller manager, like we discussed in the previous videos. So these are the Masternode components, and each of them are very much responsible for managing the entire Kubernetes, right? So these are the control plane components. That means they are the user facing, or a user typically if want to access any application deployed on the worker nodes, they have to initially talk to the control plane, and from the control plane, the request goes to the data plane, right? Or where your applications are actually deployed. So now it is your responsibility to create this entire architecture. And to create this entire thing, let's say you are doing it by yourself. First, you have to install all of these things. If you are using kubeadm, let's say you create all of these things on the master nodes. Then you go to the worker nodes, you install the container network interface, the CNI plugins. Then you install a container runtime. Then you install a DNS service, you install kubeproxy. Once you install all of these things, then your responsibility is to join these worker nodes. Let's say these are the 3 worker nodes. You have to join the worker nodes to the control plane. So this entire thing has to be done by you. This is a very tedious process, and this is error prone as well. Now you might be saying that, Abhishek, but why will I use kubeadm? These days there are so many modern days tools like kops. Okay, I agree. Using kops, you can reduce this effort significantly. You can just provide your AWS credentials, you can provide your VPC, whatever you would like to, and kops can create this entire thing for you. Now let's assume kops has created 3 master node, 3 worker node architecture for you, and you shared it with your DevOps team, development team, and they started deploying the applications. Okay. After a while, what happened is the master node, one of the master node went down. Certificate expired. API server is down. etcd crashed. Scheduler is not working. Now, these are some of the problems that I remember at this point of time. And even if you install the Kubernetes cluster using kops, kops can create the Kubernetes cluster, but you are responsible for handling all of these issues, right? And these are not small issues. To debug what happened to etcd, to debug why your API server is slow, why your API server is not responsive, or why the scheduler is not responding. Certificates have expired. You have to renew the certificates, reattach the regenerated certificates. So it will make a DevOps engineer's life very, very hectic, right? And this is just about one cluster. Now, what if you have hundreds of clusters? What if you have thousands of Kubernetes clusters? As a DevOps engineer, you have to take care of all of these things. As a cloud engineer, you have to manage all of these issues. And finally, you might set up some monitoring, you might set up some different configuration rules, and each and every day your effort will go on solving these issues. And as I told you, right from day one, whenever we learned AWS, whenever there is an opportunity, right? Whenever there is manual activity, whenever there is lot of maintenance activity, AWS will come into picture, and AWS will say that, okay, don't worry, we will create a managed service for you. And similarly, AWS said that we will create EKS for you. And now this EKS is a managed control plane. Understand this carefully. EKS is a managed control plane, but it is not managed data plane. That means what AWS is saying that, okay, go to my EKS service portal on the AWS platform and request for a Kubernetes cluster. So what EKS is going to do is EKS is going to give you a highly available Kubernetes cluster with respect to the control plane components. That means everything related to control plane is taken care by the AWS platform, right? So let's say your API server is going down, etcd is crashed, you can just ask AWS, and AWS will always make sure that those kind of issues are not happening. Now, saying that it manages control plane, but it also allows you, or it also provides you a very easy way of attaching or integrating your worker nodes with the control plane, right? Of course, it's a managed control plane, but it will also help you with respect to worker nodes. Let's say with respect to EKS, you can request for a Kubernetes cluster. AWS will install the entire control plane for you. It will create the master nodes. You will not know where these master nodes are, right? Or you don't have to bother about these master nodes. And when you attach the worker nodes, AWS EKS will give you 2 options. One is you can use your EC2 instances. So you can create the EC2 instances by yourself, or AWS is saying that you can go with options like Fargate. What is Fargate? Fargate is a AWS serverless compute, just like Lambda functions, but Lambda functions are defined for a small amount of workloads, right? So if you want to perform any quick actions, then you can use Lambda functions, but Fargates are defined for running containers. So it's a AWS serverless compute that allows you to run containers. So if you are using Fargates in combination with EKS, you don't have to worry about anything. Like EKS takes care of control plane, Fargate takes place of your worker node, right? Anything like your worker node going down or your size of the worker node, resources eating up your worker node, you don't have to bother about anything. You can deploy any number of applications, and Fargate is a service that is highly available. EKS control plane is highly available. That way you can build up a robust and highly stable, right? You can build up a robust and highly stable Kubernetes cluster using EKS. Now, I'm not saying you should not be using EKS EC2 instances for worker nodes. You can use EC2 instances for worker nodes, but then you have to take care of the high availability of it. That means you have to install or you have to configure that with the autoscaler, right? You have to install, you have to configure these EC2 instances with autoscaling so that these instances never goes down. You have to create some thresholds, you have to create some monitoring. All of that thing will be taken care by you. If you are using Fargate, then you don't have to worry about it. But talking about EKS, again, EKS is a fully managed control plane of AWS for Kubernetes, and using this, your work will be significantly less. You don't have to worry about all the issues that I explained. Like you don't have to worry about certificates being expired. You don't have to worry about API server slowness. You don't have to worry about, for example, etcd getting crashed. If any of these things is happening, you have AWS SLA with you, and you can talk to AWS. I mean, typically that does not happen. If once in a while, even if it is happening, then you can tell AWS that, okay, the SLA is breached. Now what should we do? Should we go with any compensation or whatever you have the agreement with AWS? So that's the reason why people are moving towards EKS, right? Typically, if you are on AWS platform, there are three ways of installing Kubernetes. One is you can there are two ways of installing Kubernetes on AWS platform. One is you can create virtual machines by yourself, and you can use tools like kops or kubeadm, and you can set up Kubernetes cluster without EKS. Second thing is you can go with EKS. So now this EKS adoption has increased significantly because people are finding managing Kubernetes difficult. But saying that, I will also cover a lot of drawbacks about EKS. Don't worry about it. By the end of this video, you will also learn about the drawbacks. I'm not just going to cover the pros, but there are a lot of cons as well. And the other way is, let's say you are on-premises. Then on-premises, you can just install Kubernetes cluster on your data center, right? On your data center servers. So people are moving from on-premises to cloud, and from cloud, instead of doing everything by yourself, you are moving towards the managed services. Of course, there are a lot of customers on the on-premises. People are also moving back, which we discussed, like cloud repatriation, but let's not discuss because it's a very, very less number. For now, understand that from on-premises, previously everything used to be here. Then people moved to the EC2 instances, deployed everything by themselves. Now people are moving towards the managed services, which is EKS in our Kubernetes topic today. Now this is about EKS, and these are the advantages of using EKS. Now let's talk about what are we going to learn today. Are we just going to learn how to create this EKS? Definitely not, because that is a very simple thing that even you can learn by yourself. But today's video, what I'm going to show is create an EKS cluster. Additionally, with creating the EKS cluster, what I'm going to do is, let's say this is your Kubernetes cluster. Okay. I am going to show you how to deploy an application onto this Kubernetes cluster, that is the EKS platform, and how to allow your customer or your user. Let's say we are going to deploy this 2048 application that we have seen, right? So we are going to deploy this one, and people are going to use that 2048 application. So this is my Kubernetes cluster. Let's say there are 2 worker nodes here, and there are 3 master nodes, M1, M2, M3. So here, let's say my application is deployed in the pod. So I've created a pod.yaml and I've deployed the pod.yaml using the kubectl. So what happened is my application is deployed in this pod. When the application is deployed as a pod using deployment or something, what would happen is typically this will just have the cluster IP. That means this pod can be accessed anywhere from the cluster. It can be accessed from the master node, this one, this one, this one, or even this worker node as well. Let's call it worker 1, let's call it worker 2. So it can be accessed from here as well, but end user cannot access it. And this is not what we want, right? Because my application needs to be accessed from external world. So what I'm going to do here is, for this, firstly we will create a service. Now again, service, I'll create a service.yaml and kubectl. I'm going to deploy the service. Now service is going to say that I'm going to give you 3 options. One is you can use the cluster IP model that you're using already, or I can allow you to expose this to the node level using the node port mode, or you can expose it to public using the load balancer level. I mean the load balancer mode. So service has 3 modes. Now cluster IP mode, like I told you, it will be only accessible within the cluster, anywhere from this master nodes or worker nodes. Node port, what will happen is, if you convert your service to node port model, then this pod or this application can be accessed from any of these IP addresses. Let's say all of these are EC2 instances. So people who have access to this EC2 instances IP addresses, they can access the application. But usually what happens is, this entire thing, like this Kubernetes cluster, usually will be within a VPC, right? And this VPC will have a public subnet and it will have a private subnet. And like we discussed in the previous videos, applications are always deployed in the private subnets. So again, the problem is that if you are exposing this in the node port mode, people can access it, but the people who have access to this private subnet only can access it. That means anyone, let's say there is another EC2 instance here, or let's say there is another Kubernetes cluster here, they can access it, but people outside cannot access it. For people outside to access it, you need a load balancer, right? And load balancer should have access to it, or you need a public IP address for it. Like let's say you need a elastic IP address. So that is what the load balancer mode provides. Load balancer mode creates a elastic IP address using which users can access it. But the problem is that load balancer mode is very, very costly. If you have 10,000 applications and if you create load balancer mode for all the pods using services, then you will see significantly high pricing on your AWS environment. So the best approach is to go with the Ingress resource. The reason why I'm explaining this again, I have covered Ingress a lot, but for some people Ingress is confusing. So that's why I'm explaining Ingress again. Now let's draw this diagram again. Now what we are going to do is, instead of using this, we are going to use Ingress. So for purpose of simplicity, let me just draw that node. Let me say that this is the node. Okay. So let me say that this is the worker node and this is the master node, for example. And this master node, let's say, has API server. And this is the user. Okay. So now what we are going to do here is, using Ingress, like typically there will be a pod here, right? So the pod is always there, and you have created service also. This service we will either restrict to cluster IP mode or we will restrict it to node port mode. You can put any of these things. When you are using Ingress, Ingress can support both of these things. So what you are going to do is, additionally for this, the DevOps engineer is going to create an Ingress resource. Now what this Ingress will do, Ingress will allow this customer to access the application that is inside the EKS cluster, or Ingress will basically route the traffic inside the cluster. So what DevOps engineer does is, DevOps engineer will write this ingress.yaml file, where in the ingress.yaml file you will write, allow this user to access the application on example.com/abc. If someone is accessing example.com/abc, let's say this user is accessing example.com/abc, forward the request to the service. And from the service, the request will go to the pod. So this configuration you will write in the Ingress resource, and you will deploy this Ingress resource using kubectl. But just by deploying the Ingress resource, nothing will happen, right? Because you have deployed the Ingress resource, there has to be someone who have to help you in taking this request from outside to here, right? Typically, this user cannot access anything inside, right? Because this everything is in the private subnet. But this user can access things in the public subnet. And in the public subnet, if you face a load balancer, like let's say you are placing a load balancer in the public subnet, then this user can request the public subnet, can request the load balancer, and from the load balancer, request can come inside. So there is a concept in Kubernetes called as Ingress controller. And typically all the load balancers support Ingress controllers. They have their own Ingress controllers. Let's say we are talking about Nginx. Nginx has their own Ingress controller. We are talking about F5. F5 has their own Ingress controller. And all of these things are available as Helm charts or plain YAML manifest. You can download the Helm chart and you can deploy this on your Kubernetes cluster. Let's say I have deployed the Ingress controller for AWS ALB. So as soon as the DevOps engineer creates an Ingress resource, this Ingress controller will watch for the Ingress resource and it will create the ALB for you. This is called as ALB controller. This Ingress controller is called as ALB controller. So this ALB controller will keep watching for the Ingress resources, and whenever the Ingress resource is created, the ALB controller will create an ALB environment for you, or will create an application load balancer. And using this application load balancer, user can talk to the application load balancer, and from the application load balancer, request will go to your application. Now this is same for every Ingress controller. Let's say you are using Nginx instead of this. Now what will happen is there will be Nginx Ingress controller that you will deploy inside the Kubernetes cluster. And whenever the Nginx Ingress controller will find the Ingress resource, this Nginx Ingress controller will either create a Nginx load balancer, or if the load balancer is already there, it will configure the load balancer for the rules mentioned in the Ingress resource. Like I told you, these rules should be configured in the Ingress resource. So ingress.yaml has these things, but there has to be a load balancer which has to perform these actions. And that load balancer will be your Nginx load balancer, or application load balancer, or F5 load balancer, depending upon the Ingress controller that you are using. So in market, there are hundreds of Ingress controllers. You can choose according to your requirement, right? So now what will happen if you create Nginx Ingress controller, ALB Ingress controller, and everything in the same cluster? Then you can define in the Ingress itself who should access this Ingress resource. There is something called as Ingress class. Okay, let's not deep dive into it, but just if someone gets a confusion here, I'm saying that using Ingress class, you can define who has to watch for this Ingress resource. But now I think it is very, very clear, right? DevOps engineer, along with the pod, along with the service, DevOps engineer will create Ingress for every resource or every pod that needs access from the external world. There will be one Ingress controller that will watch for all the Ingress resources, and it will configure the load balancer. External person will talk to the load balancer. From the load balancer, which is in the public subnet, request will come to the pod through service to the pod, right? So this is the entire configuration of Ingress controllers. I'm explaining this because today's class, we are going to deploy an application that should be accessed from the external world, right? If you still have any confusion, go back to my Kubernetes playlist. I'll put the Kubernetes playlist link in the description, which has everything covered in detail. For each of the concept, we at least spend 40 minutes. So please go there and try to understand it. Now, let me go back to the other screen and start with the practicals, right? So we will start with the practical in a minute. Okay, so first of all, for today's video, because I'm going to use a lot of commands and I'm going to use terminal a lot, I thought I will place each and every command that I'm using in this GitHub repository. So for the people who are following our course or our channel for the first time, so there is this GitHub repository called AWS DevOps 0 to Hero. And for each day, of course, if it is not required, I haven't created folder. But for most of the days, we have folder-wise MD files, folder-wise commands. Whenever it is required, it is available in this GitHub repository. So all that you need to do is go to this repository called AWS DevOps 0 to Hero. Link is also available in the description. And click on the day 22 folder. Then you have each and every step that I'm going to follow. For example, during the video, let's say you did not follow the command that I used to install EKS. Then you can come here and this is the command. You can just copy paste it. And similarly, once you install EKS cluster, then how to add the plugin. So each and every command is available here. So please follow this thing if you fail to understand something in the video. Now, I have logged into the AWS console, right? So this is my AWS console, and let me go back to the EKS screen. So just search for EKS, Elastic Kubernetes Service, click on this. And before I start creating EKS, let me tell you that there are some things that you have to install on your laptop. To interact with EKS, to create EKS cluster, there are a bunch of things that we are going to do today. That is, the very first thing is you need to have kubectl installed, right? Kubectl needs to be installed because using kubectl, we interact with this Kubernetes cluster that we are going to create. So if you don't have kubectl, don't worry. Again, that is available in the GitHub page, how to install kubectl, how to install EKSCTL. There is one document called prerequisites.md. Here you have kubectl, EKSCTL, AWS CLI. And let's say that you want to try it now. What you can simply do is search for kubectl download. Okay, so here you have Kubernetes page where you can search for install tools, and here you have kubectl installation for Linux, kubectl installation for macOS and Windows. So you can choose accordingly and you can install kubectl. On my machine, I already have kubectl, so I don't need to do anything, like I don't have to install. So after kubectl, the second thing that you're going to install is EKSCTL, right? So again, for installing EKSCTL, just search for EKSCTL download. So click on this button, installing and updating EKS. So here there is an option called installation, right? So click on this button, installation. And I am taking it in a different tab. And here you have for which environment you want to install EKS. If it is for Unix, choose this script. If it is for Windows, choose this script. If you are on Git Bash, let's say there are some people on Windows who are using Git Bash, then you can use these commands. On Docker, macOS, everything is available, right? So you can choose accordingly. And on my thing, again, EKSCTL is already installed. So if I just do EKSCTL, this should be the output. For Mac, it is very simple. You can just say brew install or brew cask install and your EKS is installed. But don't worry, you can follow the same steps as I have shown and you can install EKSCTL. And final thing that you have to get ready is the AWS CLI, right? So in multiple videos, I've shown you how to install, how to configure AWS CLI. But just to repeat one last time, basically, you need to search for AWS CLI command line interface. And here go to the documentation. And then you have the user guide. Once you go to the user guide, to the left side, you have an option for installation, right? So here, get started, install and update. So you can follow this same document and you can proceed with the installation depending upon your flavor. And once you have installed, the final step is you need to configure it, like go to your AWS command line and click on a button, click on the command called AWS configure. So once you install, you can verify the installation using AWS version command. And okay, this is working fine. Now what you need to do is type a command called AWS configure. Now once you run this, it will ask you for access key ID, secret access key. Default region is okay and default output is also okay. But you need to have both of these things, right? So how do you get the access key ID and secret access key? You can simply go here, click on the down arrow, go to security credentials. And within the security credentials, if you scroll down, there is a section where you can find the access keys and access key ID. Let's say you don't have this, you will have this button enabled called create access key. Click on that, you will get the access key ID and secret access key. So that way you can configure your EKS as well. Sorry, AWS CLI as well. So now we have everything ready. for the purpose of this demo, I'm using my root account because I have to grant so many permissions if I'm not using root account. And because many people are doing it for the first time, I don't want to confuse by using any IAM and granting permission each and every time. So for the purpose of demo, just use the root account. Now let's go back to the EKS screen. So the very first thing that you will do is you will start with creating EKS cluster, right? So to create the EKS cluster, either you can come here and you can add cluster, click on the create button, but you need to provide a lot of parameters. And usually in the organizations, you don't do this. One of the most preferred way in organizations is to create these clusters using EKS CTL, right? What is it? EKS CTL. So EKS CTL is a command line utility that is used to manage EKS clusters. And the command that you can use here is basically this one. So you can say EKS CTL create cluster -- name. If you are wondering where I'm getting these commands from, I'm using the same GitHub document that I am shared in the description and I've shown at the beginning of the demo. So change the cluster name here from -- or -- name. Let me call this as demo cluster. Region, let's use it as US East 1. Let's use that region. And the reason I'm choosing Fargate, like I told you, for the EKS cluster, you can choose data plane or the worker nodes, either Fargate or EC2 instances. Fargate is better for these purposes unless your organization has any requirement. Like if your organization has requirement that your worker nodes have to be with a specific distribution, like your worker node should be on RHEL distribution only, or your worker nodes have to be on RHEL distribution, or your worker nodes need to have some specification, then go with the EC2 instances. If not, you can go with the Fargate by default. There are other things as well. Like I told you, I'll explain the differences as we go through the video. But for now, I'm using Fargate. Now click on the enter, and this is a very good utility that will create the entire cluster for you. Okay, there is some error here. It says EKCTL demo cluster already exists. Okay, that's fine. The reason for that is when I was performing a demo at my end, I might have created with the same name. So let me change it and call it demo cluster 1. Okay. Click on the enter button. And now what happens under the hood, or what exactly is happening, is this EKSCTL is creating everything for us. Now, what does everything mean? You can search that by click on the add cluster button. Now, if you click on the create, if you see, first of all, it requires some service roles, right? And then it requires, like if you click on the next button, it requires some configuration related to networking. Like, you need a public subnet, you need a private subnet. Whereas this EKSCTL, what it does is it creates a public private subnet for us. That means it creates within the VPC, it creates a public subnet, it creates a private subnet, and in the private subnet, we will place our applications, right? So all of these things is taken care by our EKSCTL utility. Isn't it good? Now, this will take 15 to 20 minutes. In some cases, it might be done in 10 minutes. In some cases, it can be 5 minutes. So please be patient here. And in my case, previously when I did it, it took some 12 to 13 minutes. And if your network is good, it will take less than that. If your network is bad, it will take more than that. So please be patient here. Wait for the control plane to become ready. Okay, so now the cluster is created, and it took some 16 minutes for me. So I've paused the recording, and yeah, so in your case also, please watch it. If it takes more time, then it's still fine. Unless it is failing, you have to be patient. Or let's say it failed for some reason, there is a good chance that it can fail as well due to some latency issues, due to some connection issues. So don't worry, you need to patiently wait for it. Now, the cluster is created. Let's go to the console and see if the cluster is reflecting here. So search for EKS. Perfect. Now, if we look at the cluster here, go to the cluster section. Yes. So this is the cluster, right? Demo hyphen cluster hyphen one. So the cluster is created. This is a kubectl, this is a Kubernetes version. This is a default version that we got with the EKS CTL, but you can also change this version. But for now, you can keep it. So demo hyphen cluster hyphen one. And if you scroll down, you can see everything in the console. So this is another advantage of using EKS. That is, there is a resources tab. And if you click on that resources tab, you can check the resources that are available on your cluster. For example, you don't need to go to your command line and type kubectl get pods. You can just see here what are the pods that are available, right? You can change the namespace here. Let's say you want to check in kube system namespace. So here you can see what are the pods that are running. Let's say you want to search for daemon sets, right? Or you want to search for the service accounts on this cluster. You can search here. So this is another advantage of using EKS. Of course, this kind of features are available in most of the Kubernetes distributions, but with the plain Kubernetes, unless you install dashboard by yourself, you don't get these kind of features, right? Perfect. Now let's take a look at the overview of the cluster. I just want to show you a few things here before we jump on to the next things. So the overview says that Kubernetes cluster is created. This is my API server endpoint. And this is my OpenID connector provider URL. Now, what does this mean? What is an OpenID connector provider? Basically, with this Kubernetes cluster that we have created, you can integrate any identity providers. For example, in your organization, you have an identity provider, which is like, let's say you have Okta, you have Keycloak, or any other identity providers. Let's say you are not aware of identity provider. Identity provider is something that, for example, LDAP is an identity provider where you have created all your users for your organization. You can create all the users in an identity provider, and you can attach that identity provider to multiple other things. For example, these days, when you go to any applications, you will see login with Facebook, login with Google, right? So what is happening there? There is an identity broker where you can attach an identity provider. So there, Facebook, your Google, they all serve as an social identity providers where you can attach that identity provider to the identity broker. In this case, what AWS does is AWS allows you to attach any identity providers so that for this EKS, you can manage. One is you can use IAM, of course. If you don't want to use IAM or if you want to use any other identity providers, you can also integrate with that. And in this video, I am going to integrate IAM identity provider. The reason is that if you don't integrate IAM identity providers, let's say you have created a Kubernetes pod, okay, and this pod wants to talk to S3 bucket, or this pod wants to talk to the EKS control plane, or this pod wants to talk to any other AWS service like CloudWatch. If you're not integrating the IAM identity provider, how will you give access to this pod, right? Usually in AWS, what we do is whenever a AWS service wants to talk to other AWS service, or whenever a resource in AWS, you have created an instance in EC2, you have created an application in EC2. If this application wants to talk to S3 bucket, we need an IAM role, right? Similarly, whenever you create Kubernetes pods, you can attach or you can integrate that IAM roles with your Kubernetes service accounts so that you can talk to any other AWS services. And then if you scroll down, you have other options here. If you scroll up, the resources I've just explained. Then there is compute. In our case, we are using Fargate. If you see here, so the Fargate instances are available here. One thing is we are not using EC2 instances or something. If we are using EC2 instances, you can see the EC2 instances, or you can create node groups as well. Right now, if I create node groups, I can attach some EC2 instances. Then there is a Fargate profile. This is very, very important. What this Fargate profile says is right now the Fargate profile is attached to the default and kube system namespace. That means you can only deploy the pods onto these two namespaces. If you want to deploy pods to any other namespaces, you have to add additional Fargate profile. I'm going to show you because in the video, I'm going to use a different namespace and I'm going to deploy into a different namespace as well. So there you can see how to create Fargate profile and how to attach that to this cluster or to this Fargate instances. Perfect. Then networking, we will not change anything. And authentication, like I told you, you can attach any identity providers here. Logging, if you want to attach the control plane login, let's say that you want to log all the API server requests, then you can click on manage logging, enable the API server logging and click on the save changes. But for now, I don't need anything. So let me keep it in. The next thing that I will do is I want to download the kubeconfig file so that instead of always going through this resource tab and verifying from here, because we are all DevOps engineers and we are very used to the kubectl command line for Kubernetes. So let me get that kubectl command line, right? So to get that kubectl command line, you remember we installed EKS right? So let me do this command called update kubeconfig. Okay, so this is the command. And what does this command do? AWS EKS update kubeconfig. What is the name of the cluster? So in this case, name of the cluster is demo-cluster-1. Region is US-East-1. Click on the enter button. It will again take some time. Okay, perfect. So let's proceed with the deployment of actual application. So let's go step by step. First of all, I'll deploy the 20848 applications pod using the deployment. Okay, so for that, what I am going to do is, let me go to my GitHub. Perfect. So this is the first command that I'm going to run. So this command says, let me show you from where I'm copying it. So I'm using the same GitHub repository. I'm not changing anything. So I just copied this command from the GitHub repository. And the first thing that I'm doing here is I am creating a Fargate profile, like I mentioned. The reason why I'm creating the Fargate profile is, if you see here, I am attaching the namespace called 2048 game. I can deploy it in the default namespace as well, but I just want to cover one additional topic. That's the reason why I'm creating a Fargate profile as well. There is no other reason. You can create in your default namespace as well. So demo cluster 1, US East 1, ALB sample app. I'm providing the name as a sample application. And this is the namespace where I'm deploying game 2048. So click on the enter button. Now this will create a Fargate profile. I will show you on the console that the Fargate profile is getting created. See, what is it saying? Creating Fargate profile, ALB sample app on EKS cluster. This is the name of the cluster. So once it is created, if you go to the compute section and scroll down, you should see another Fargate profile. Along with default and kube system namespace, you should also see the game 2048 namespace. Let's wait for a second and see if that is getting created or not. Perfect. Now the Fargate profile is also created for us. Let's go to the console and see. Let me refresh this page. See here, there is another profile and the namespace here is game 2048. So now what's happening is I can create instances in both of these namespace and also this namespace. Now you might be thinking, Abhishek, why I have to do this for Fargate? So this is a simple concept, like if you are using the bare metal Kubernetes, or if you are using Kubernetes that you have created, there is a concept called pod affinity, or you have node affinity, anti-affinity, right? Whereas with Fargate, you have this concept. So this is very unique to Fargate. And every time you want to deploy to any namespaces on Fargate, you have to do it, right? Whereas if you are using EC2 instances, you can avoid this step, but that's a different process. Cool. Now I have the Fargate instance as well. So let me take my application from the GitHub, right? Now what I'm doing again is I am going to this 2048 app deploy ingress.md and I am copying this command from here. Okay. So now what will happen is this specific command kubectl apply -f followed by this file, right? Now what is in this file? So this file has all the configuration related to deployment, service, and ingress. You can also read the contents of this file. Take this file and open it in a browser. See what exactly it is trying to do. Let me increase the font. So it is creating a namespace called game2048. Previously we created Fargate profile and we allowed deployments onto the namespace, but we don't have the namespace itself. So I'm creating the namespace called game2048. Then this is the deployment, right? For the 2048 application. Then this is the service that I'm using again. So if we go step by step in the deployment, all that you need to mention is the pod specification, right? And as part of the pod specification, you see that this is the container image. So you can use the same container image to deploy the same 2048 application that I'm using. And the replica count I have mentioned as 5, just to make sure that if there are multiple requests, this will still be able to tackle. Now I've taken this example from the EKS official documentation, so you can also use it as is. After that, so this is the service that we are using. So what the service does is you need to take the service for two things. One is you have to make sure that the target port is the container port of your pod. And the second thing is you have proper labels and selectors, right? So if you see here, the selector is app kubernetes.io name app2048, and this selector should match this specific thing here, right? Sorry, this specific thing here. So labels app kubernetes.io name app2048. So this way, what is happening is my service will be able to discover the pods. So using this label, using the concept of labels and selectors, service will be able to discover the pods. Perfect. And after that, I have created an ingress. So like I told you, what we are trying to do with ingress, we are trying to route the traffic inside the cluster. So I have a couple of annotations here. So don't deep dive into these things at this point of time. First of all, let's try to do the demo. And once you get a gist of it, we can go ahead. But if you see here, like I told you in the theory part, what you will do with ingress, you will just mention that if someone is trying to access the load balancer, so the ingress class name here is ALB. That means we are going to use application load balancer, ingress controller, that will read the ingress resource, and whenever it finds the matching rules, it will forward the request to service called 2048. What is service 2048? This one. And where is this service 2048 forwarding the request? To this one, available in this namespace, right? This is the entire concept of this YAML file. I just wanted to explain you people so that you also understand what exactly is happening behind the scenes. Click on the enter button. Now each and every resource will be created. But keep in mind that we are only creating pod deployment service and ingress, but right now there is no ingress controller. That means there is nothing on the cluster that can understand this resource. I haven't deployed the ingress controller. So without ingress controller, I can say that this resource is a useless resource because nothing will happen if you just deploy this. So let's see if I'm right or wrong. So I'll just search for kubectl get pods -n game -2048. So the pods are in the pending state. It will just take some time, but once the pods are created, let's watch the pods. See, one of the container is in running state and the rest all are getting created. I think by now everything is created. Perfect. All the pods are in running state. And now similarly, you can search for service kubectl get svc -n game -2048. Perfect. The service is also running state, and watch carefully. The service has the cluster IP. The type is node port, but there is no external IP. That means anybody within the AWS VPC or anybody who has access to the VPC, they can talk to this pod using the node IP address followed by port. But our goal is to make someone outside the AWS or someone who is your user or customer should access this thing. So for that, what we have done is we have created an ingress, right? So kubectl get ingress -n game -2048. So if you see here, Ingress is created. It is saying this is my Ingress. This is the class. Host can be anything. I mean, anybody who is trying to access the application load balancer, that is fine. There is no address. There is port, but there is no address. That means there has to be an Ingress controller. Once we deploy the Ingress controller, you will see the address here. Why is this address useful? You have to access this specific address to access the application from outside world, right? So the address is not created because there is no load balancer or there is no Ingress controller. Now what we are going to do next is we are going to create an Ingress controller. That Ingress controller will read this Ingress resource called Ingress-2048 and it will create a load balancer for us. It will not just create the load balancer, but it will configure the entire load balancer. Now, what do I mean by configuring load balancer? Creating load balancer is fine. Just creating an ALB will do nothing again. Inside the ALB, you have to configure what is the target group. You have to configure on what port should it access the pods. Everything is created and taken care by the Ingress controller itself. All that Ingress controller needs is an Ingress resource. Perfect. So to deploy the Ingress controller, in our case, to deploy the ALB Ingress controller or just ALB controller, because we want to use application load balancer, the first thing that you will do is again go to my GitHub here. The reason why I'm showing document multiple times is because I want everyone to try, because this is a very, very important thing. Now, there is one option here called configure OIDC connector. So this is a prerequisite before installing or before going to this page called ALB connector add-on, right? You can directly do this, but it will fail without the OIDC connector thing. Like I told you, the reason why we need IAM OIDC connector or IAM OIDC is because the ALB controller which is running, it needs to access the application load balancer, right? This is a ALB controller. So controller is nothing but a Kubernetes pod again. So this Kubernetes pod needs to talk to some AWS resources. To talk to AWS resources, it needs to have IAM integrated. So that's why we need to create this IAM OIDC provider. Now, this is done in every organization, and every organization, usually if they're on AWS, they prefer to use the IAM OIDC provider itself because they might have spent a lot of time creating everything for users. So copy this command that is in the document. EKS CTL utils associate IAM OIDC provider. If you think that you have seen this somewhere, yeah, you have seen it when I showed you the cluster, right? This is the cluster. If you go to authentication tab, you see this thing called OIDC identity providers. And here you have associate identity provider. That's what I'm doing from the command line. So I'm just associating the IAM identity provider, change the cluster name, demo-cluster-1, approve. Click on this button. Now the identity provider, IAM OIDC provider will be integrated. Perfect. This is also done. Now let's head to the final step. That is, go to the document called ALB connector addon.md. So this is the document that I'm talking about. So this will be your final steps where you will use this specific thing in my day 22 ALB connector add-on. So go step by step here. The first thing that you will do is you are trying to install a ALB controller, right? So ALB controller in Kubernetes, any controller is just a pod. Okay, but for this pod, what you are trying to do additionally is you are trying to grant this pod access to AWS services such as ALB, right? Because this ALB Ingress controller should create an application load balancer for us. For that, it has to talk to the AWS APIs. So firstly, let's create a IAM policy for this one. And we will create a IAM role as well. So the IAM policy is, I have already created this JSON. So you can, as it is, create this JSON. So here I have created a IAM policy for it. If you want to take a look at the policy, what's inside it, just copy it, go to your browser, and within the browser, enter this, you will see the exact JSON what I am trying to do. So this is a very big JSON and you need to grant all of these permissions, right? Perfect. Now the next thing that you will do, now you don't worry, this is a standard process. There is nothing that you have to change here. You might be thinking, Abhishek, you just gave me this one and you are just entering the command. How will I learn about it? No, you don't need to learn anything here because this is provided by the ALB controller itself. You can get this from the ALB controller documentation. And if there is any change, they will provide you the changes. Okay, so I have taken it from the documentation itself. Just I'm keeping everything in one place in my GitHub repository. Then create the IAM policy using this command. All of these things are required for the ALB controller creation. Did I miss something here? Let's see. AWS IAM create policy. This is the policy name. It says that, okay, entity already exists. So there is a policy that already exists in my account. Let me enter this command again and show you what has happened here. When calling the create policy operation, a policy called AWS controller policy already exists. Okay, to be fair, what I'll do is I'll go ahead and delete it, because let's say you run into this error again, you might feel that Abhishek, you already have it, so that's why it is successful on your cluster. So let me go ahead and delete it so that we all will be on the same page. Go to the policies, click on this one, provide what is the name of the policy, right? This is the one, and delete the policy. Search for it, select it, actions, delete. Perfect, the policy is deleted. So let me create it one more time. Now I have created the policy, right? The final thing that we'll do is we'll create the role. I think the role will also be available. So let me go ahead and delete the role as well, because I tried previously, right? Every time before I show you something, I will ensure that it is working, and I will ensure that twice or thrice everything is working fine, because anybody who is following these videos, I want them to perform the demos. Perfect. Let me delete this one as well. And this is a very, very important thing for your resume. So anybody who wants to show proper experience on Kubernetes, this will definitely help them. Now, the final thing is I am creating the role. I mean, I'm attaching this role to the service account of the pod, right? That's the whole purpose, right? Like I told you, whenever the pod is running, the pod will have a service account. And for that service account, you need basically the role attached so that it can integrate with other AWS resources. So here I have to modify my AWS account ID. So whenever you are copying from my GitHub, make sure that you replace. That's why I have also not provided any account name there. So perfect. This is my account ID. And then what I'll do is, what is my cluster name? Modify that as well. Demo-cluster-1. Perfect. I hope this will be created. Fingers crossed. The role is getting created. I mean, the IAM service account is getting created, and it is also getting attached with the role. So now we will use this same service account in the application, right? So this is how you do in your organization. Basically, you create some service accounts, or developers create some service account depending upon the requirement that they have. Let's say the developers want to talk to RDS. What they'll do is they'll create a service account and they'll ask you to create a role with specific permissions. See, here it said that one error occurred and IAM role stacks haven't created properly. You may have to check the CloudFormation console. Okay, let's try it one more time. So sometimes you will face such errors. Don't worry, we will try it one more time. See, now it got created. Service account that exists will be existing service account. Okay, let's see if there is something that goes wrong. I can fix it during the live demo. So I hope everything is correct, but let's see if something goes wrong there, I can fix it. Now let's try to proceed with the creation of that application load balancer that we have been talking about. Sorry, the ALB controller that we have been talking about. So for that, we are going to use the Helm chart. And this Helm chart will create the actual controller and it will use this service account for running the pod. Okay, it is already existing on my account. That's fine. Then let's see if there is any updates to the Helm chart. Perfect, there are no updates. So now let's install the Helm chart. So again, while installing, you have to modify a couple of things. One is your VPC ID. How do you get the VPC ID? Just go to your demo cluster, and within the demo cluster, if you go to the overview, there should be somewhere, I think in the networking tab. Perfect. So this is the VPC, just copy paste it. Then region, you know what is the region? US East 1 in my case. Then provide the cluster name. Demo-cluster-1. There is some white space here. I think it is okay. Yeah, we can remove this space. Perfect. Click on the enter button. Expected at most 2 arguments, unexpected arguments. Okay, let us see what went wrong there. Okay, where is it actually going wrong? Why does it say like that? Let me try to add it here. Let me try this. Yeah, I think there is some white spaces issue. I'll try to update this command in my GitHub page as well, so that you don't run into this issue. So now here I'm using the Helm chart to install this AWS load balancer controller. So again, this will take some time, not much time. Maybe it will take some. Yeah, see here, AWS load balancer controller installed. Now, one final check that you have to do is you have to verify that this load balancer is created and there are at least 2 replicas of it. Okay. See here, till now, the ready state is 0 of 2. When it becomes 2 of 2, that means your load balancer controller is working fine. Okay, because what this load balancer controller deployment does is it will create 2 replicas, one in each availability zone. It will continuously watch for, like I told you, ingress resources, and it will create the ALB resources in 2 availability zones. Okay, so let's try it. Not yet. We can keep this in the watch state so that if there is any update, we will come to know. Yeah, this will take 1 or 2 minutes for both of the replicas to be up and running. Meanwhile, you can also do this kubectl get pods -a. Sorry, minus. This is created in the kube system namespace. Okay. Just watch for it. Okay, not yet getting created. Let's wait for a minute. Okay, I waited for some time. Still, the replicas is 0 out of 2. If you see here, it's 3 minutes and still the replicas is 0 out of 2. So now let's troubleshoot and fix this. What is going wrong? Okay, so how do I do that? Just you can do kubectl edit deploy. Now in your case, this is not needed. I know why this is happening on my cluster. In your case, if you follow the same commands, you will not run into this issue because I did the demo before. There are some stale resources. That's why I think I'm running into it. So let me copy paste this one. So I'm trying to debug it. So let me go to the kube system namespace. Here, if you go to the status field, usually you will see what is the error, or else you can also do the describe. So what does it say? pods AWS load balancer controller is forbidden. Error looking up service account kube system AWS load balancer controller. If you remember, when we were creating the service account, then we saw the issue, right? So this was the service account command that we have used. And when we tried to create the, okay, not this one, service account. Yes. So this was the service account command that we tried to use. And when we were creating, it gave an error that, there is a cloud formation that is already available. So that's why the service account was not getting created. So let's try to fix it. Now we need this service account. Only once it is created, then we will solve that error, right? So let's try to fix it and let's try to redeploy the deployment. It says service account that exists in Kubernetes will be excluded. Use override service account. I'm overriding the service account. Like I told you, in your case, this might not be required. Because I was using the same cluster for the demo, that's why we have this. Metadata of service accounts that exist in Kubernetes will be updated. So let's see now, because we have overwritten, if it works. If not, I'll go to the CloudFormation templates, I'll delete it and I'll fix it back. So troubleshooting is very common when we do the demos, and that is also good, right? Okay, so the service account got created here. The only thing that I had to modify was there was an error with creation of service account. So what I did was I have updated the name of the service account. In your case, you don't have to update it, but in my case, there was a previously existing one. So what I've done is I went to the CloudFormation templates, which was creating this service account, and I've deleted the stack that was creating this service account. And for a safer side, I have also updated the name of the service account, because sometimes it takes some time. So I have updated it. But in your case, it is not required. Now let's proceed with the next one. This one here, right? So we have created the deployment, but because the service account was not proper, so that got deleted. So let's go with the creation of deployment one more time. So here I will update the name of the service account as well. Again, repeating, in your case, it is not required. Let's say for some reason you will also land into this issue because of some network issues or something. How will you debug? Just go to the stacks, CloudFormation stacks, and delete the stack that was creating the service account. Because sometimes because of some intermittent network issues or something, also this might happen. Now let me try my luck. Now I'm hoping that cannot reuse the name that is still in use. Okay, that is because the Helm chat. Let me just delete the Helm chat. Helm delete. This is the advantage of demo, right? So whenever I do some issues, I will fix it and you can also see it live. Now let's rerun the command. Fingers crossed, hoping this to work fine now. Perfect. Now the application load balancer is installed, but the main thing is the pods have to be in running state. kubectl get deploy -n kube system. So the available replicas have to be 2 by 2. Till then we need to wait. So let me see again in the edit section if there is some error. kubectl edit deploy followed by this -n kube -system. Okay, at least now there is no error till now. So I think it is getting created. It will take some time. Okay, still not created. Perfect. Now it got created. If you go to the deployments as well, you will see 2 by 2 replicas. Perfect. So this is the perfect state of application load balancer controller, not application load balancer. This is the AWS load balancer controller or application load balancer controller. Now let us see if this AWS load balancer controller has created a ALB or not, right? So if we go to ALB, That means if we go to EC2 and inside application load balancers, you need to see a load balancer. Perfect. I'm seeing a load balancer, and this load balancer has to be just created. See, it is just created August 4th. The time is 1:57 and here it is 1:56. So that means it is just created. And what is the name? K8's game 2048. And how this is created? This is the whole logic you need to understand. So who created this load balancer? This load balancer controller has created. How did it create? Because we submitted a ingress resource. kubectl get ingress -n kube-system. So here, sorry, hyphen game hyphen 2048, right? So that was in the game hyphen 2048 namespace. And this ingress resource here, we got the address. So this address over here, what does this what exactly is this address? So this address is the load balancer that the ingress controller has created watching this ingress resource, right? So I have previously also explained the ingress controller will watch for the ingress resource configuration provided in the ingress resource and create a load balancer. Now let us see if it is correct or not. So if we go to the browser here, and if you go to the load balancer section, right? So here you will find a load balancer. Let me increase the font a bit. So see, this is the load balancer, and if you click on the load balancer that got created, this will be the same IP address. So if I copy paste this one, and if you try to compare that on here, so see, this is the same specific IP address, right? So this is the same thing that is available in the address section. That means the ingress controller has read the ingress resource and created this load balancer. Now what you need to wait is you need to wait till this load balancer state is active. Now this took couple of minutes for me. Previously it took 3 to 4 minutes. This time it took 2 minutes only. But in your case, be patient. Wait till this status turns into active state. And meanwhile, you can also verify what are the other configurations that are available here. For example, on which port is it listening, right? What are the security groups? Everything is configured by the ingress controller itself. Just by watching this, you will get little bit more information, but wait for the status to be active. Now, once the status is active, what I'll do is I'll just copy this URL, click on a new tab, and as soon as I click on the enter button, http:// this one, right? Copy and remove this /. Perfect. So this is the 2048 game, and now you can play this game and let me know in the comment section who has got the highest score. Just kidding. But yeah, so this is what we exactly deployed, and we are accessing the load balancer, and through the load balancer we are getting the request. Right now I think you have understood how this entire load balancer is created, how usually this works in an organization. So for each microservice, it is responsibility of DevOps engineer to just write the pod deployment. I mean, if they are using deployment, they'll write the deployment.yaml, service.yaml, ingress.yaml, and it is your one-time responsibility to create the ingress controller. And rest is taken care by the ingress controller. So that is what we have seen in today's video. Because it is EKS cluster, the configuration of ingress controller is little bit tricky, because we have to create a service account and we have to attach that service account with the IAM profile or IAM role. But otherwise, on an on-premises Kubernetes cluster, this much is not required. You can just assign service account with proper RBAC. Anyways, this video is to explain things through EKS. So I hope you found it useful. Please let me know in the comment section what is your take on this one. Are you going to try, and are you going to share it with your friends and colleagues? This is a very good addition to your resume. Thank you so much again for watching this video. Take care everyone. See you all in the next video. Bye bye.